Hello everyone, this is our project Gridwise Analytics, which is a dashboard for Becken protocol or for UEI on Becken protocol. Gridwise is an innovative dashboard solution designed for grid managers, enabling real-time visibility into flows across the grid power by UEI. By leveraging the Solana blockchain, so we have it here. By leveraging the Solana blockchain, we and the ledger and smart contracts, Gridwise securely tracks and stores energy transactions. Uh, such as renewable energy trades, distributed storage through simulation scripts and real-time data. So you can see all the scripts here. Our dashboard provides a key insight into peak demand supply surplus energy release and P2P trading. This open analytics tool empower grid operators to optimize energy capacity, predict trends, and ensure sustainability with full traceability of renewable energy sources. So let me give you a demo. So here, what we are doing is first we are registering grid. This is just a simulation that we are doing on the same contact address that we have connected here, and we have wrote some simulation scripts that uh, yeah. So here we have wrote some simulation scripts that pushes these that creates grid, then charging stations and all of these things, and then create simulated transaction on our smart contract, and then we fetch all those transaction and map everything here. So as you can see, everything here is mapped and connected to our wallet. So let me give a demo. Here is our grid ID, and our grid name is let's say MHACB, which is a Maharashtra grid. HACB. Latitude we'll choose random, and then total power supply would be suppose 10 megawatts. Uh, we'll create a new account for this. I'll just go with the random public key, and then user would be our current wallet, and then I'll just test it. So you can see we are currently connected to devnet, and it created this on the devnet. And if we see the grid for this address, so you can see the grid is actually registered. And now we'll create a charging station and a power generation point. So if we see a grid, if we have a grid, then obviously there would be a consumption and a generation side. For this simulated part that we are doing here, we are taking the consumption part as a charging station that is already built. The infrastructure is already built on UEI for this, and the generation point would be anything that is like generating and sending energy to to this specific grid, and doing a payment transaction, like the grid is doing payment transaction to this power generation point via this charging station. So suppose charging station uses energy from that grid, it will pay to that grid, and then the grid will pay to this generation points, which will be power plants. So yeah, we'll create a station, charging station. So the name would be Shell Charging, suppose. Okay, latitude random. Power rating would be, I would say, 0.5 megawatt, or I'll go with 5 megawatt for as like we have restrictions here for decimal. So yeah, 5 megawatts, and then I'll go with random ID and current wallet. I'll copy this, and yeah, I'll create this also, and I'll do the same with the power generation point, plant name. So now I'll see all the things here. I can fetch the power plant, and also, sorry, charging station, and also the power plant. So you can see all these things are fetched, all these things are for simulation that we are fetching into our dashboard. So now I can do a transaction which will reflect on the dashboard. So this is our custom transaction ID. This is for generation that will be generated from our generation source, or basically this address. And yeah, I'll enter a grid address, which is this. So we are creating a transaction on this grid, and this transaction will be called from the Becken protocol implementation, basically the UEI implementation. And the power amount will be, I would say, 1 megawatt, 1 megawatt entered to the grid. And transaction ID would be random, and I'll test. So you can see the transaction is added, and we can see the transaction here. So we'll just put the transaction. We can fetch the transaction. You can see the transaction is that happened on this grid. And if I go to if I go to our script, we can fetch. You can see the transaction. We can fetch all the transaction and filter it by the grid address, and we are just putting all these values for this particular grid on this thing. So we are also storing timestamp, as you can see here, for every creation of every entity, and that is how we are reflecting everything here. So we have created some test transaction already before this demo, and reflected everything here. So we have supply versus demand trends, which automatically detects for a certain time period. So you can see from this to this date, due to the timestamp that we have added. Then this P2P transaction is just hard coded, because we don't support as of now. And this supply demand mismatch is happening from the supply increases, and there is no demand. Then the fluctuation, we are same again doing it from the basically the power generation, total power generation and consumption at a certain point, basically certain timestamp. And this is the cost that the users are paying for using. And basically the generation point, we have to pay to the generation point. So yeah, this is the whole. And also we are doing predictions using ML model, basically linear regression. And you can see uh, the prediction data here. And using this, the grid operators can easily predict the future transactions that will be happening on the UI on their UEI interface. So yeah, that's it. Thank you for watching.